Okay, in 9.5, our objective is to describe the effect on area. We're not going to worry about perimeter. On area when one or more dimensions of a figure are changed. So to do that, what we're going to do is I'm going to look at what's happening to the area if we just change one dimension. So one thing, like what, the base or the height or something like that. Just one side of a shape. So for question number 1, it says, what happens to the area if the height of a triangle is multiplied by 6? So to do this, we're going to do the long way. To do this the long way, we're going to do 3 things. First, we're going to find the area of the first triangle or the old triangle before we change the dimensions. So for a triangle, it's base times height divided by 2. That's how we find the area. And we can tell that the 5 and 12 are our base and our height because they are perpendicular. So 5 times 12 divided by 2 gets us 30. So that's the area of the old triangle, because now we're going to change the triangle and make it new. So the area of the new triangle, we're still going to use base times height divided by 2, but this time it says that the height is going to be multiplied by 6. So we're going to take the height, we're going to multiply it by 6. So 5 times 6 is now 30. We're going to use 30 for the height and 12 for the base. And we're going to get that, let's see, 30 times 6 is 180. Okay? So this is the area of our new triangle. The last thing we're going to do is I want to see what's happening to the area. Notice it's not asking me what is the area. It's saying what's happening to the area. Most of you are going to say, well, it's getting bigger. Hello, we're multiplying by 6. Yeah, I know it's getting bigger, but how much is it going to get bigger by? That's what we want to figure out. So to find that, we take the area of the new and divide it by the area of the old. And that's going to tell us how much bigger the area is going to get. So we had 180 divided by 30, and that gets us 6. So that means that the area is going to be multiplied by 6. The area is being multiplied by 6. The height is also being multiplied by 6. So when we're changing one dimension, we're doing the same thing to the area. So whatever we do to one dimension, we do the same thing to the area. So looking at number 2, it says the height of the rectangle is tripled. Looking at what happened in our first example, we could say that the area is also going to be tripled, which is the same thing as saying it's being multiplied by 3. But if you don't believe me, that's okay. We'll go through the same 3 steps as last time. So to find the area of the old rectangle, that means before we've changed it, we know the area is just base times height. So 4 times 7 is 28. Do the same thing. Now we're going to change the rectangle, and we're going to find the area of the new one. This one says that the height of the rectangle is going to be tripled. So we're going to take 4. Now we're going to multiply it by 3. Now our new rectangle, the height is going to be 12. So we're going to do base times height again, but this time we're going to use 12 times 7, and that's going to be 84. And then the last thing, remember to find what's happening to the area. You take the area of the new one and you divide it by the area of the old one. So you're going to take 84, divide it by 28, and oh my gosh, you get 3. That means the area is going to be multiplied by 3 if you change one dimension by 3 as well. Multiply one dimension by 3. Okay, so the pattern is if you change one dimension by a number, and let's say that number is A, what's going to happen to the area? You're going to be multiplying the area by A as well. So the shortcut is that what you do to one dimension, so let's say we multiply it by A, you are also going to do to the area. So our area is going to be multiplied by A as well. And remember, A is just any number. Okay, so go ahead and see if you can figure out what the answer for number 4 is. If you take one dimension of a kite and you multiply it by 1/3, what are you going to be doing to the area? All right, so I'll check that and see if you guys get that one correct. So that was all changing the effects, what happens to the area if you just change one dimension. The other type of question I'm going to ask you is what happens if you change both dimensions. So if you change both sides or both, all the dimensions of one figure, what's going to happen to the area this time? We said before, if we change one dimension, if you multiply one dimension by a number, any number a, then you're going to also change the area by multiplying it by a as well. Okay, so let's do the long way for number 5 and see if we can notice a pattern. So it says the base and the height of a rectangle are 8 and 3, and they're both going to be multiplied by 5. I don't care about the perimeter at this point. I want to figure out just what's happening to the area. And notice it's not asking what is the area. It's saying what happens to the area. How much is it getting bigger or smaller by? So again, like we did last time, we're going to find the area of the old one. Then we're going to find the area of the new one. And then we're going to figure out what's happening to it by dividing area of new by area of old. All right, so the area of the old rectangle, we have 3 by 8, and we know that the formula for area is base times height, so 3 times 8 equals 24. The area of the new one, now both the base and the height are multiplied by 5. So instead of using 3 and 8, we're going to say 8 times 5 is 40, and 3 times 5 is 15. So again, we're still using base times height, but we're using these different dimensions. So 40 times 15 is 600. And then our last step is we're going to take those two numbers and we're going to divide them. So 600 divided by 24 is telling us that the area, what happened to the area is it was being multiplied by 25. It got bigger by 25. Okay, so again, we took what was happening to one dimension. We said it was being multiplied by 5. We said what was happening to the other dimension. It was being multiplied by 5. If we multiply those two numbers together, we get 25. Okay, so you take what's happening to one dimension. Let's say you multiplied one dimension by A, and let's say you changed another answer by B. The effect on the area is going to be A times B. So whatever you multiply the dimensions by, if one number is, let's say 2, and let's say you multiply the other dimension by 3, what are you going to be changing the area by? Well, you changed 1 by 2, and you changed another dimension by 3, so that means the effect on the area is going to be multiplied by 6. The area is going to be 6 times bigger. Okay, and that's because you're changing all the dimensions. For a circle, that's a special shape, and where the radius is the only dimension. So you're going to treat it like it happens twice. Okay, so the shortcut, let's see if I can figure out the shortcut. I'm saying that the radius is going to be changed by 1/5. Now, that means I changed the radius for one time by 1/5, and I'm going to say that it happens again because the radius is the only dimension, and usually there's 2. So I'm going to say that the other radius also is being multiplied by 1/5. And 1/5 times 1/5, 1 times 1 is 1. 5 times 5 is 25. So I'm going to say that the area is going to get smaller by 1 over 25. It's being reduced by 1/25. Okay, so to check my work, though, some people are not going to believe me. Let's do the long way. The area of the old circle, that area is pi r squared. So the radius is 10. 10 squared is 100. We have 100 pi for the old circle. Now we change the circle. The new circle is being reduced by 1/5. So 10 divided by 5 is 2. Now our r equals 2. So for pi r squared, we have pi times 2 squared. 2 squared is 4. All right. So the last thing we do is we take the new one and we divide it by the old one. So we have 4 pi divided by 100 pi. The pi's cancel out. And 4 over 100, does that reduce to 1 over 25? Oh my gosh, it does. So you can always do the long route if you want to. It does not matter to me if you want to do all these 3 steps. That's fine. But if you can see the pattern, it would just be faster. That's it. So if you change both dimensions by A, or in the case of a circle, if you just change the radius by A, and again, A is any number. What are you changing the area by? I don't care about perimeter. The area is going to be a times a, or a squared, because you're changing one dimension. You take what you do to one dimension and you multiply it by what you do to the second dimension. And that's going to be what happens to your area. All right, so you can either try to use this shortcut if you understand it, or you can use these 3 steps if that's what you prefer. It really doesn't matter to me. I want to see if you can figure out what happens in number 8.